Hello students, welcome to my YouTube channel. In this video lecture, we are going to look at new questions from Airfield chapter, Keith Williams' performance book. Now, performance is a very important topic when it comes to your CPL exam, ATPL exams, and also your type rating training, right? So you will have to execute performance calculations like density altitude, pressure altitude, takeoff distances, landing distances, your speeds, rate of climbs, descent, etc. Be it CPL flying training, ATPL exams, or your type rating training when you go for your sessions. So understanding of this knowledge is very important. In my previous video lecture, I solved the first 10 questions from this particular chapter. Apart from that, I have also solved all the questions from chapter 1, Atmosphere, from this particular book, Keith Williams' performance book. So do watch those video lectures if you haven't yet. So let's begin with new questions now. Question 11. A field is unbalanced when? Now, a field will be called a balanced field when it satisfies a balanced field. It satisfies one of the two conditions. The first condition being clear way, the length of the clear way equals to the length of the stop way. Second, there is no clear way, neither clear way nor a stop way on the airport. Okay, this makes satisfaction of any of this condition makes a field balanced. Now, here they are talking about unbalanced field. Unbalanced field will be the opposite of a balanced field. So there is no clear way or stop way. So unavailability of a clear way or a stop way makes the field balanced. Next, the clear way length is equal to that of the stop way. Even this condition will make a field a balanced field. The clear way is longer than the stop way. The clear way is harder than the stop way. So option Charlie is the right option. Whenever the lengths of clear way and stop way differ or are not equal, the field will be called unbalanced, right? So here the clear way is longer than the stop way, hence the field is unbalanced. Now the clear way B is harder than the stop way. This is irrelevant because the criterion states that the lengths of the clear way and stop way should be equal for them for the field to be called a balanced field. It doesn't specify any load bearing strength or the strength bearing capacity of the surface of the stop way and the clear way. Okay, so that's why delta is wrong. And another point, clear way need not be harder than the stop way because it's not the job of the clear way to hold your aircraft in position or to decelerate your aircraft and hold it in one position. It's the job of the stop way to hold aircraft in one place, decelerate it and hold it in one place if that aircraft aborts the takeoff and tries to stop it. Okay, so stop way helps in achieving that deceleration and stopping of aircraft. The stopway is made of such a material which helps in achieving that aim. Okay, so clear way does not need not be harder than the stopway because most of it is in the atmosphere. Stopway, the entire stopway is on the ground, but clear way, most of it is in the atmosphere, so it cannot be harder or softer than the stopway. It's irrelevant. Question number 12. A field is unbalanced when there is no clear way or stop way. So no clear way, no stop way, field is balanced. Clear way length equal to stop way again. This condition will make the field balanced. There is a clear way but no stop way. There is a stop way but no clear way. So option C is the right one. And a field is unbalanced when there is a clear way and but no stop way. Okay. So Charlie is the right answer. So field is unbalanced when when the clear way is longer than the stop way or stop way is longer than the clear way. And second condition when there is a clear way but no stop way. Okay. Next. Remember this. 13. A field with a stop way but no clear way is not permitted, is unbalanced, is operationally flexible, is balanced. Okay, so a field with a stop way but no clear way will be called unbalanced, will be called unbalanced. Now, out of the four options given, the option B is the most appropriate one. But by definition, an unbalanced field is one where there is a clear way but no stop way. But look at the options, four options here. Option Bravo will be the safest one. It's not permitted. There is no such case. It is permitted. Is balanced? Not at all, because balanced field conditions are stop way and clear way must be equal in length, and second condition is that no stop, neither stopway nor clear way. But here there is a stopway but no clear way. So delta is wrong. Charlie. Now stopway. When you have a stopway but you don't have a clear way, so your takeoff mass with which you can take off is limited by field field lengths. Okay, that means it's a disadvantage. It's a disadvantage. Okay, so option Bravo is the right one. And whenever there is a clear way, we get operational flexibilities. Okay, but just a stop way, we do not achieve that. We do not have that provision. Question number 14. A balanced field improves flying gradient. Okay, balanced field means when stopway and clearway lengths are equal. So improves flying gradient, is more operationally flexible, makes calculation of takeoff performance more simple, is shorter. So option Charlie is the right one. A balanced field means accelerate stop distance available equals to takeoff distance available. So when the field is balanced, calculations become easy. 15. Runway 27 threshold elevation is 200 feet. So let's draw this. There is a runway, north datum. This is runway 27. This is runway 09. Now the elevation is 200 feet above mean sea level, and runway 09er is 150 feet above mean sea level. Okay, so the mean sea level is something like this. So that means if you are taking off from runway 27, if you are taking off from runway 27, what will happen? You will experience a down slope. That means your runway is something like this. Okay, okay, this part, runway 27 part is lifted, okay, is higher than runway 09. The runway 27 part is higher than the runway 09. If you are taking off from runway 09, what will happen? Take off from runway 09. So you will experience same thing. You will experience an upslope. So from runway 09er upslope, if you are taking off from runway 27, you will experience a downslope. Okay. Next. Takeoff run available is 1200 meter. So takeoff run available, this entire takeoff run available distance is 1200 meter. Accelerate stop distance available is 1400 meter. What is the slope of runway 27? So the formula is slope equals to difference in elevation, difference in elevations of the two sides of the runway divided by takeoff run available distance into 100. Now, slope will be equal to, what is the difference in elevations? 200 minus 150, 150 minus 200. So, since you are taking off from runway 27, pay attention, runway 27, right? You are taking off from runway 27, you will experience a down slope, okay, a negative slope. So in order to get a negative slope, you know this. Looking at a picture, we know it's a negative slope, a down slope. So we need that negative sign. That negative sign is possible when we subtract 150 minus 200. Okay, and takeoff run available is 1500, correction, 1200 meter. Now we know that 150, it's 150 feet, 200 feet, and this is 1200 meters. So convert this into corresponding feet. We know that 1 meter equals to 3.28 feet. So 1200 will be 3.28 into 100. So minus 50 into 1200 into 3.28. 3936 multiplied by 100. So minus 5000 divided by 3936. So it is 1.27%. So we have a downslope of 1.27%. A downslope of minus 1.27%. So option Bravo. Next, question number 16. Runway 27 threshold. So draw a runway. 09er. So runway 275 and 310. So now runway 09er is higher than runway 27. 7 is 275 in 310. Mean sea level is something like this. Next. Runway 27 takeoff run available is 900 meter. Runway 09er takeoff run available is 1100 meter. So here we have different takeoff run available. We have different takeoff run available. For runway 27 it is 900 meter, and for 09 it is 1100 meter. That means we have a displaced threshold. We have a displaced threshold near runway 09er. Okay. So takeoff run available with respect to runway 09er is 1100, and so what I'll do is I'll draw another diagram. This is your runway 09er, let's say. So for runway 09er, takeoff run available equals to 1100 meter. Another runway diagram. For runway 27, takeoff run available equals to 900 meter. So now formula. The formula is we are taking off from, so what is the slope of runway 09er 0? That means we are taking off from runway 09er. When we take off from runway 09er, we will be experiencing an upslope. Okay, because runway 09er is 310 feet and runway 27 is only 275 feet. Correction, we will be experiencing a downslope. So runway 09er is higher than runway